Welcome to Learn Fast tutorial. If this is your first time of seeing my video, consider subscribing. Follow my page. Please like and share this video to your friends. On this tutorial, we have a logarithmic equation problem. Log 3 base x plus log x base 3 is equal to 10 over 3. And we're asked to solve this equation. So the best way to go around this problem, if we take a good look at these logarithmic expressions here, you will see that for this and for this, they are not of the same base. So the first thing we need to do to make our work a lot more easier for us is to, look for the logarithmic equation that is best to make the same with the other. And in this case, remember that we are looking for the value of x. We are interested in getting the value of x. So we are going to take the inverse of this logarithmic expression here to make the base the same with this. This is what I mean. So we are going to have log 3 base x plus 1 over log 3 base x will be equal to 10 over 3. So getting the inverse of this will automatically make them of the same base. So this is the first step we are taking to solve this problem. And then the second step is we are going to denote, since we have the logarithmic expression of the same base and everything the same, we are going to denote them by an alphabet. So by so doing, it's going to also help us solve this problem fast and easier. So let's log 3 base x be equal to p. Anywhere we find log 3 base x, we denote it by p. So let's log 3 base x be equal to p. So back to what we have here, we have p plus 1 over p will be equal to 10 over 3. So from here, we are going to multiply both sides by 3p. The reason is to make, now when we multiply by 3p, we are going to get rid of these fractions, and also at the end is going to give us a simple quadratic equation. So if we multiply both sides by 3p, we have 3p squared plus 3p over p will be equal to, and when we multiply 10, we'll have 30p divided by 3. And then remember that something can go here. When 3 goes, we'll have 10, and then this and this can cancel out. So we are left with 3p squared plus 3 will be equal to 10p. So if we collect like terms, we are going to shift 10p to the left hand side, and the sign is automatically going to change. So we have 3p squared minus 10p plus 3 will be equal to 0. So this has given us a simple quadratic equation. And we're going to look for two numbers using the factorization method. We're going to look for two numbers. Recall that the product of 3 and 3 here is 9. So we're going to look for two numbers that upon addition will give us negative 10, but upon multiplication will give us positive 9. So those two numbers are negative 9 and negative 1. When we add negative 9 and negative 1, we have negative 10. And then when we multiply negative 1 and negative 9, we have positive 9. So we are going to substitute negative 9 and negative 1. Then in this case, negative 9p and negative 1, negative p for negative 10p. So we're going to substitute these two numbers for negative 10p. So if we do so, we have 3p squared minus 9p minus p plus 3 equal to 0. This is still the same thing with what we have here, because when you sum these two, you are going to obtain what we have here. And so Yeah, using the factorization method, we can find out that 3p is common in these two terms, right? So we take out 3p, then we have p remaining, and also we have 3. So that when 3p multiplies 3, we'll still obtain 9p. And in this case, -1 is common. So have -1, then for p we'll have p, and for 3 we'll have -3. So that when -1 multiplies -3, it will give us +3. So this is the point where we are now. So we're going to take out the factors from this. Now remember that what we are using here is the factorization method. So we're going to take out the factors. So we have 3p and -1. So we have 3p -1, and then we also have p minus 3 as the two factors. So now we're going to make each of them stand alone. So we'll have 3p minus 1 will be equal to 0, or p minus 3 will be equal to 0. And so 3p will be equal to 1, while p will be equal to 3 in this case. But then we're going to divide all through by 3, right? So p will be equal to 1 over 3. But then recall that what we have as p is log 3 base 10. So remember that log 3 base x, will be equal to p. What we have as p is log 3 base x, like we said here. So do not forget this. So what this means is log 3 base x, because log 3 base x is equal to p, and p is equal to 1 over 3, or p is equal to 3. So we can say that log 3 base x also be equal to 1 over 3, or log 3 base x will be equal to 3. Then if we evaluate x from here, this becomes the power of x. So we have x raised to power 1 over 3 will be equal to 3. And then x, this becomes the power, will be equal to 3. So we want to make x stand alone. So we are going to multiply the power by 3. Now, if we multiply 3, 3 is going to cancel 3. Then x will stand alone. And then we'll also multiply by the power of 3 here. So x will be equal to 3 raised to power of 3, which will give us 27 for x. And in this case, we are going to multiply the powers, both values, we're going to multiply both sides by the power of 1 over 3 to make sure we make x stand alone. So we'll multiply 1 over 3, 3 cancels 3, yeah? Then we're left with 1 over 3. So this also means that x is equal to 3 raised to power of 1 over 3. So what this means is that x, and if we write this in short form, is equal to the cube root of 3. So this is the actual answer to this question. Now x can be equal to 27, or x will be equal to the cube root of 3, which is the correct answer to this problem. So it is quite simple if you understand the steps and the necessary moves you are supposed to make, trying to also make your work simpler so that you don't have to solve for a very long time before you get your answer. It is quite understandable and comprehensible. So I hope you do enjoy the video. Hope to see you on my next class. Make sure you like this video. Make sure you share to your friends. Hope to see you on our next class. Bye.